Okay, right. So this week, I thought, well, we're doing Leaflet. I was hoping to do Leaflet and Ajax, but there really wasn't quite time to do that. So we'll probably have one final Cody lecture after the break. So, and that will be the last of the sort of coding lectures. So today is all about Leaflet and the Leaflet mapping application, and then I'll describe and we'll talk about the assignment and what you need to do for the assignment. To a certain extent, this is me just working my way through some of the practical materials that are in the practicals, and that may seem a little perhaps unnecessary, but I think there's certain aspects of the coding that it helps for me to talk about them, as opposed, because I might not have gone into so much detail in the writing, or I might have discovered new things since I wrote that document. And even though people got that instruction manual or got similar instructions last year to what you're getting, some people felt that they hadn't got enough help with using the Leaflet mapping environment. Previously it was Google Earth API people were using, so people asked for additional guidance when it comes to the programming, hence this lecture, but I'll try. So, Leaflet. Leaflet is an open source JavaScript library for making maps on the World Wide Web. It's one of many that are out there. There's Google Maps API, which was probably the first, was the first sort of publicly available mapping program, web mapping program. There's Open Layers, which is like Leaflet, but has far more functionality and is a much larger program. And there's a whole variety of other libraries out there as well. Leaflet. What's special about Leaflet? Well, it's probably, if not now, the biggest web mapping application. It's up there with one of the most number of sites use Leaflet, so it's very widely used, it's very popular. It's what I would regard as sort of one of the sort of second generation mapping libraries. Initially we had the Google Maps API, which is still used a great deal, is still very popular. But to some of the functionality in the Google Maps API, you need to be able to program at a kind of slightly lower level than you do with Leaflet. Basically, as the mapping programs are further developed, it becomes easier to do things because the libraries are built so that you can do a particular job with maybe 1 or 2 lines of code, whereas before you may have been in the Google Maps API, you maybe need 20, 30 lines of code to do that thing. It's lightweight, which means it loads up quickly and leads to responsive web maps. For example, well, we've got approximately 38 kilobytes. The Open Layers API is up to 1 megabyte, so significantly larger, so much slower to load up. It's designed as simplicity, performance, and usability. And the other thing is it's got good documentation and there are many examples out there to help you develop your code, so it's quite well documented. And there are additional plugins. So Leaflet provides a variety of sort of what you could call basic functionality, tools for doing, making sort of relatively simple maps, but people have extended it with these plugins that allow you to do other things as well. So, simplest type of map, simplest Leaflet map is just a map without any additional information on, just a base map. That's where we'll start. So to make a Hello World map, Hello World being sort of the first program you write in any particular language or with any particular library, that's what we'll do now. So we need an HTML web page. which has a link tag pointing to the Leaflet CSS file. So Leaflet has a CSS file for which controls how things are displayed on screen, things like that. To be honest, I don't know a great deal about the Leaflet CSS file. You just include a reference to it for the CSS component of Leaflet. You also need a script tag pointing to the Leaflet JavaScript file. You need, in the body of your document, you need a div element. A div is a divide, stands for division or division, divider. And it's basically was originally developed to sort of split a web page up into sections. But in fact, a lot of the web graphics web libraries draw their graphics within a div element. So it's very common for libraries, graphics libraries such as Leaflet, to draw their graphics in a div. So Google Maps also draw their maps in a div element. So we define a div element, and we have to set the ID attribute. And this is effectively, that div is the map container. It's the container on the web page that the map's within. And finally, we need a script tag that references your JavaScript file that actually builds the map when the page loads, that creates the map. So those are the 4 components of your web page. Then you have a CSS file that's different from the Leaflet CSS file that defines the page contents. And in respect of the map, you have to define the size of the map div, otherwise in Leaflet the div has a size of 0 and your map will be invisible because there's no size to the div. And finally you have your JavaScript, which is referenced by this tag here, that defines the map contents and any interaction that's going on with the map. So here is a Hello World HTML file on OSGeo Live. So this is just on my OSGeo Live. So we've got your head. In our head, we've got the link to the Leaflet style sheet. Now, my Hello World HTML file is in the root web directory, the dot. Whereas I think in the instructions for you, I've said you're still putting them in your user directory, so the Leaflet is a subdirectory of the root folder in the web directory. If you're in user, you'll need 2 dots to go up the directory structure and then down into Leaflet. So OSGeo Live comes preloaded, supplied with a local copy of Leaflet. So I'm referencing the local copy of the Leaflet CSS file. Down here, I'm referencing the local copy of the JavaScript, the Leaflet JavaScript. Here, I'm referencing my CSS file. And finally, in the body, I've got my division. The ID attribute is set. It's called map, my sensible thing. And then finally, I have another script tag down here, which is calling my program Hello World JavaScript that draws the map in the div. Now, the script tag that draws the map, or the script that draws the map, has to be defined after the division in the web document. Otherwise, there's an error thrown, if I remember correctly. And that is why this script is under the div in the body rather than up in the head. So the browser reads the div, then it reads the script, runs the script, and the div element exists, and it can work. If I had this script tag up here, then it would try and run the script before the div tag exists, and it would fall over. However, there are all sorts of ways whereby you can defer the running of a script and things like that by putting extra tags in the script here So we could put this script tag up here, but with extra attributes that say basically defer running this script until the whole page is loaded. So you may see different leaflet map examples with some people running their scripts here, some people running their scripts here with additional attributes and things like that. So there are different ways of getting the same result. That's what I'm saying. So you may see different configurations. And that's our HTML page. Our CSS is quite advanced, as you can see. The hash is the ID, so ID map, the element with the ID map, which of course is our div here. So it's saying ID equals map. We're going to set the height to 400 pixels. So we're setting the height of that div, this div, to 400 pixels. Then we have the Hello World JavaScript code that runs after the div is created in the HTML document. So I know a number of you were doing this, starting this last week. We have declare a variable, which is just a string, which is providing a hyperlink to Google Maps, and that's going to be put in as part of the sort of copyright description on the map. So it's just a string which has a link to Google Maps. So that's what we declare there. We then declare a variable called Google Layer. Google Layer is set to a leaflet. The L, the big L stands for leaflet, but everything that you do with leaflet is going to start with a big L. Big L dot, that's the method, remember, tile layer. So what we're going to do is we're creating a tile layer. A tile layer is it's like a web map service in that it delivers maps as images. But it's a different format and a different way of doing that. I don't think it's officially an OGC or British standard yet, but it may be, but it's certainly on the way to becoming one. So we're going to create a tile layer, and in this tile layer we're going to display some Google basic map. We then, you can see this is the tile layer, starts there, stops there. Okay, we pass into the tile layer a URL to the Google Maps tile server. Okay. It's perhaps not the standard URL, but you can see it's a URL with parameters. This S we can basically ignore in the curly brackets, but the way I understand it, it's to do with these subdomains. The way I understand it is tile servers are set up so that they can only respond to a request from a client so many times per minute or second or something like that. So to get around that, what people do is, what you do is set up multiple servers that do the same thing. Then Leaflet, what happens, these little curly brackets basically mean the program Leaflet will insert something into there. So what it does is, I think what happens, and I'm not 100% certain, is it takes these subdomains, these 4 subdomains, basically inserts these into here, and therefore it can make requests to 4 different Google servers, which are serving out the same type of information, rather than just one server. And because one server is limited on how much it can talk to each client, if you send your response to your needs or your requests to 4 different servers, then you can get 4 responses. It's basically parallelizing the map tile request service. And really, that's all about, that's the level that I know it as. We don't need to know any more than that. We then have that's the address of the tile server, and then we have a LYRS layers argument, which is equal to S. S defines a Google satellite image, the satellite image. Other letters in there will return other types of maps. We'll see those in a second. Then we have another series of arguments, x equals x, y equals y, z equals z. These are the x, y, z coordinates of what you're looking at on the map. So x and y, obviously, your latitude, your longitude of your map. Z, your zoom level, your height. Then, in the curly brackets, there's a set of optional parameters that are being sent in to the tile layer. We can see we've got an attribution value, which is just the string, map data, copyright sign, and then the link to Google Maps. So that's going to be displayed, I think, in the bottom right-hand corner as a sort of copyright notice. We have the maximum zoom level at which to display this layer. The zoom levels go in Google Maps, and I think in general go from 1 being 12 being, 1 is sort of the whole world being really, really high zoom level, so you see a large area. And as the numbers get larger, you're getting closer to the Earth now. I can't remember exactly what they go to. Is it 15, 17, 16 levels? I'm not sure. But basically, you will see the map, the satellite image, until you get to zoom level 12, and then when you go below zoom level 12, you're not going to see the satellite imagery anymore. And then we've got our list of the subdomains that basically get pumped into this S to parallelize the delivery of the maps. So that creates a variable which kind of points to the Google satellite tile layer. Then we have a final line of code, define map, and this is what creates the map in the division. So we create a map. Now, we don't actually need to create a map variable here. We could just put lmap and just do it without saving the result in a variable. So that's actually unnecessary. But, so we set our map variable to the l.map, which means draw a map. Then the first argument is the name of the division, the ID of the division that you want to draw the map in, because you may have several maps on the same page. Then we have a set of map options in the curly brackets, passed in as an object. We have one called center, which is just the center of the map in latitude and longitude. The minimum zoom, the zoom at which you can, that's the minimum zoom, so that'll be the zoom that you start, the maximum height at which you see the layer or see the map. The zoom level where we're starting at 1, so we're going to start up seeing the whole world. And then the layers, an array of layers that we're going to add to that map. So at the moment, we're only going to add the base map layer, Google map layer. Oops. And that code, we put all that to code, put hello world, and there we go. There's our attribution. There's our link to Google Maps down here. So I think the leaflet bit is automatically put in by leaflet, and then that attribution was that map data, copyright, Google Maps there. And we've got automatically, it's built with a zoom bar, a sort of a zoom control on. And there it's our hello world map. Yeah?
You said that the X, Y, and Z are the coordinates of the map.
Sorry, the
X, Y, and Z.
Yeah, these are basically being passed as you pan on the map. Okay, so initially we're saying the center is 0 and the zoom level is 1. So X and Y are 0 and 0, okay? And the zoom level Z is 1. So when the map's first drawn, these are the default values. Then you pan and zoom on the map. If you pan or zoom on the map with the controls, inside Leaflet, all these figures are being updated are passed to Google and the map's returned and displayed in the box. So it's doing all that automatically for you. That's all.
To get like a map with Zoom 7, for example, you have to specify the coordinates.
If you want.
Like more specific map.
Yes, then you would change the center coordinates. You'd change your zoom level until you were over the area that you were interested in, where you wanted to draw the map. Yeah. I'm doing global stuff here, so I'm not really. Yeah. Okay, we can also build these maps, as I discovered yesterday, in JS Fiddle. So here we just need the map division. I put some body tags. I don't think the body tags are even necessary in there. I can put the JavaScript in here, in the JavaScript window, unsurprisingly, put my CSS up here. And then for the links to the CSS files, the leaflet files, because I don't have local leaflet files on JS Fiddle, what you can do is you just press that plus, and then you paste in the web address of the CSS or the JavaScript file that you want to be referenced, and then they get automatically loaded up here. So these are the web addresses of the Leaflet CSS and the Leaflet JavaScript libraries that are provided by the Leaflet website. So it says, so this is loading the latest release, stable release of Leaflet from the web, whereas before with OS Geo, I was opening what was probably an older version of Leaflet that's locally on OS Geo Live. You have the option of either referencing the latest version online, in which case you get all the new whiz-bangs, but there's a danger that at some point they'll do something to the Leaflet code that might break your application. So if you're pointing to the web release, you may be getting the latest, fastest version, but it may eventually break your code because they change some of the syntax of the Leaflet distribution, and then you don't notice, or your maps just stop working one day. If you want to maintain stability, then you copy a local version of the Leaflet version that you're going to use. Then you've got that local version being referenced. It's not going to change. And then when you decide you want to update your application to the next version of Leaflet, then you go and down the latest version, do the debugging if any is required, an update. So there are pluses and minuses of pointing to the web version of these files or using the local version as well. So that's quite fun just for playing around with parameters. This is a good way. I quite like, I've never used JS Fiddle before the last couple of weeks. And, you know, it's okay just for playing around and learning little bits of code. I'd advise using it. Right, so we've got a basic map. What else can we do to that basic map? Well, one of the simplest things we can do is add map controls. By default, we have a zoom control. We can turn that off if we don't want the user to be able to zoom in and out on the map. We've got the attribution that we've already seen, that we've sort of seen that tested out. We can also add a layer control, and that determines what layers are visible, basically turning on and off layers in the map. And we can add a scale bar. Okay, so just doing this one in JS Fiddle. So again, exactly the same map. I've now got a Google layer and an OpenStreetMap layer. Okay, I get this code for OpenStreetMap. I just, get it from some of the examples online. Sure if you went to OpenStreetMap and looked it up, I'm sure we could find that as well, but I just got these from the examples. And you can see the very similar format for looking for getting the tile layer from OpenStreetMap. It's not exactly the same, but it's similar. So we've got two base layers. Then I create a variable called base layers, which is an object creating the two values, two key value pairs. The Google layer variable is assigned to the value, the key value Google satellite. This is the name, the word that's going to appear in the layer control when you pull it down. And then I have the OpenStreetMap, the key pointing to the OpenStreetMap layer that was created here. We define our map. By default, I'm loading the Google layers, making the Google layers visible, this one, satellite imagery from Google layers. Then finally, once I've made the map, I can add a control. So I can add a layer control, l.control.layers. I want to add the base layers, the 2 base layers here. And then I want to add this layer control to the map. That's this. I then put a L control scale, so a control object, a scale control object, and I add it to the map. And there's my scale object down in the left-hand side. Now, you may well be able to configure, there may be parameters to configure the scale object, to configure the base layers object, the base control object as well. Now, let's just see whether I can get that running in my JS Fiddle. Let's see whether I got that one. Is that running? No, I never got that one as far as that. I didn't save it. I was having trouble saving things on these. Maybe this one works. No. Okay, we'll see an example of what happens. We'll see what happens with the pull-down menu. Oops, we don't want to see my email, do we? We'll see what happens with the pull-down menu. Basically, this menu, when you click on it, it pulls down. We'll get a little box, the 2 base layers, and also that allow us to turn on and off toggle on and off those two base maps. Should have had an image of that. Okay, let's get some data on the map. So we've got a base map. That's base map, tile maps. Okay, which are probably, tile layers are probably the most commonly used base maps on Leaflet because they're nice and easy to run. We want to load data on our own data or somebody else's data up onto our map. We need to use access. In JavaScript, there's an object called the XHTTP object. And the XHTTP object opens files, local and remote files on the basis of a URL, and allows you to read the data in those files. But the XHTTP object has to use it natively, you have to wrap it up in code that does things like check that the data connection has been made, checks that the data is loaded, has a timeout value in case how long do you wait for the server to provide the data before you give up? So it has to be wrapped in lots of code to actually access the data files. But there are lots of libraries that provide tools for making that easy and take away the heavy lifting for you. And one of those is jQuery. jQuery is another web library, a JavaScript web library. And it's used it provides a set of tools that allow you to basically edit the document object model in various ways. It provides tools for sort of making event handling. Event handling is when you click on something like a button and then something happens. You handle the event of somebody clicking on a button. Animation tools and AJAX, the calling of behind the scenes calling of data files and querying of APIs. So it provides a whole lot of tools for basically building and developing web maps. And I did think about using jQuery throughout this part of the module to do all the base manipulation of the web elements, the pull-down lists and things like this you might create. But I decided against it, partly because I'm not familiar with the jQuery syntax myself. The other problem is that it really helps to actually write the native code yourself when you're starting to learn. Otherwise, I find if you try just diving straight into these libraries, while you may be able to do some things really quickly, it can also be detrimental to sort of the overall learning process about understanding how the language operates. Anyway, so what we're going to use is just use jQuery to open local and remote files. That's all we're going to use jQuery for. But you can do lots and lots of stuff with jQuery. Have a look at it. Okay, so we're going to make that map. We're going to load that country map on. How are we going to do it? Okay, so my load country HTML is exactly the same as my Hello World HTML. The only thing that I've got is an additional link, which is grabbing the jQuery, the latest jQuery version of jQuery off the web. I could have a local version of jQuery, but I'm not bothered with it. I'll just grab the latest one off the web. So my JavaScript, I create my map. Okay. First thing I do is I create my map. There's no base map here, so there's no tile server, there's no base map, just loading that data up. Okay, so I create my map. Now, then I'm going to read the AJAX, read the JSON file and load it in. That's the code that it looks like. However, before we get into that, I want to just talk about scope, because we need to understand the concept of scope in programming. A scope of a variable is basically where that variable can be seen from in the program. So some variables are hidden from parts of the program, others are visible to all of the program. So you need to understand a little bit about scope. So there are two types of scope. There's local and global, basically. Global variables are declared in the main program and are visible from everywhere in your code. What do I mean by the main program? The main program is we're running. Well, let's go back up to here. So the main program, so we run hello world.javascript. What happens is the code picks up and it starts running this program. This is the main program. It calls hello world JavaScript. It sequentially runs through these items of code. However, variables that are declared within functions have local scope and are visible within the function that they are defined and by any functions called by that function. That's the way I understand it. So, down here, if we go now, here's a function, and I'll talk about why the function's there and what it's doing in a minute. There to there is the function, and all the variables, polystyle, there's only one variable declared in this function, is within the function definition, and that polystyle is not visible anywhere else in the program. It's a local scope. It's only visible within this function. If you happen to have done some not so great programming, or because you're using libraries that other people have written, you might end up with a local variable with the same name as a global variable. That's possible, in which case the local variable takes precedence. Okay, so that's the difference, local and global variables. Okay, so we've created our map. Now let's load our GeoJSON onto the map. So the file countries.geo.json contains GeoJSON polygons for each country. So we start off with jQuery. The $sign, whenever you see this $sign, that means jQuery, or that's the signifier used by jQuery. Of course, another library could use $ as well, just like another library could use L for it's the same one used by Leaflet. So L dot is Leaflet, $ is jQuery. it has a function called, or a method called getJSON, which basically loads a JSON file, GeoJSON, and it can be loads a JSON file of which GeoJSON is one type of flavor. The first thing that's passed in is the URL of the JSON file. Now that can be a web address. Here it's just a local file. I'm in the local folder world.json-master, which was just the name that when I downloaded the file and unzipped it, it happened to be the directory it was unzipped to. So that's the URL of the GeoJSON file. Then, comma, and the second argument is what's called an anonymous function. It's a function without a name. Function, and then it has this word data there, a variable data, an argument data. This function starts here and stops there, and data is basically this function runs if the jQuery GeoJSON request is successful. If it fails, it would throw an error, and we haven't been dealing with error catching here at all. So if it successfully reads the JSON file, this function runs, and data is the contents of the GeoJSON file, or the JSON file. In the function, we define a variable called polystyle, which has two values: color, which is the fill color to display the polygon, and weight, which is the weight of the line drawn around the outside of the polygon, the exterior. So that's defining our style. Then I add the GeoJSON. I use the Leaflet GeoJSON function, or the Leaflet GeoJSON method, which I pass in the data that we got out with getGeoJSON. Then we have, and this will read the GeoJSON. Reads the JSON file, or the GeoJSON file that we've got, the GeoJSON data that we have. It uses a style parameter to display it on the map using the polystyle defined here, and then we add those GeoJSON features to the map. So this is a function that runs if the data is successfully returned. Now, this whole $getGeoJSON down to the end here is something called a closure. Now, I'm hanging on with my fingertips with closures. They're hard, they're difficult to get your head around. But basically, the way I understand closures is that data, this data here, is basically trapped within the closure. It's a security thing. Okay, you don't want, everything is wrapped up. This getJSON method wraps everything up tightly to prevent, it means you can't get this data out of here. You have to do everything that you want within the closure with that data. So the data gets sort of trapped within this anonymous function, and so we couldn't say, write a global variable var data, and then within here say var data via global data, say, and then global data equals data. We couldn't get the data out like that because it's a closure. This is one of these cases where, you know, I'd love one of you to go away and say, I read about closures and I understand them totally now, and I can come and tell you exactly how closures work. But it's one of these things that you just, to a certain extent, do without needing to know exactly why, but know the restrictions of it. Okay, so there's our closure. So getGeoJSON, the URL of the GeoJSON file, I've said that. We've got the drawing style, I've said that. Drawing styles, the drawing styles for polygons are defined as leaflet path objects, which is not a very handy name, I think, to think, oh, I'm going to style my polygon, I need to look at a path, don't I? Yeah, it's not what I think of. But there's the reference linked to the path object, so if you need to know what other parameters you can set here, you can look that up. And then we use the GeoJSON, Leaflet GeoJSON, as I said, to add the polygons to the map, and that's the map that we get. Brilliant. Okay, how can we enhance that map? Pop-up menus. Nice to stick a pop-up menu, always good. How do we do that? Unless I say, take you back to HTML and CSS, that all stays the same in these examples. We define our map. We use jQuery to load, exactly like we did before, to load the data up. In the GeoJSON method in Leaflet, one of the options that we can pass is called on each feature. On each feature runs, so basically GeoJSON, so say we've got 50 GeoJSON objects in our file, 50 countries, okay? GeoJSON is basically running through those 60 or however many countries you've got. It's applying a style, and then for each feature, each item, object in that file, it then runs this function on each feature. And this is where we can define pop-up menus. So basically, every feature that's being processed, we can run a function on that can do some more stuff on it. Okay. So when this runs on each individual feature, it's going to call a function called on each feature. Here's my function on each feature, which is defined elsewhere in the program. My function is called on each feature. It has two arguments, feature and layer. Every Leaflet on each feature method has to have these two arguments, feature and layer. Now, the feature is the individual feature that's being processed, and the layer is, in this case, the individual GeoJSON object. I am still having trouble in understanding exactly what the difference between feature and layer is. I've never had to use layer yet. That's why I don't really fully understand it. Anyway, you do it like this. You pass the feature and the layer. Then what this function does is it looks at the feature and it says, right, okay, does this have, okay, so we're first of all setting a pop-up text, and our pop-up text is going to be what we saw before, string ID, then the feature ID value, the value of the ID field for each country. Then we're going to have a carriage return, that's just HTML. Then we're going to have name, colon, and then we're going to get the feature, the properties, the name. So the ID is just the integer ID of the field of the feature, and feature properties name is the name of that country, the attribute, name attribute of that country.
So, for example, if you about like database, that would be sort of a table behind.
That's right, yes.
How do you know what's there to call it?
Okay, so there are you could look at the structure of the GeoJSON file. Okay, you can also look at. I think I worked it out in the debug window, which I talked about last week, which you missed, of course. Is that if you do, you know roughly the structure of the GeoJSON file by looking at it in a text editor. Then I just basically experimented. I knew there was an ID field in there, so I could just do feature.id and see whether I got a result or not. But yes, you need to know. Basically, you're going to get all your fields, presuming it's just a simple GeoJSON file, standardly things built from a table. All your properties will just have one dot name for the name field, dot whatever for each of the fields. And then there's feature dot, I think there's another one for geometry, but I haven't got that yet. This is the first year I've done Leaflet, so there's a lot about Leaflet I don't know. I'm hoping to be taught by you lot when you build your applications. So you've got an opportunity here to really shine, because I'm not a Leaflet expert. This is my first year on Leaflet, and I'm still learning the ropes myself. Okay. We create a new property called pop-up content, which equals the pop-up, the text. This should have gone actually before. Oh no, well, okay. So we then add the text that we created that's going to go in the pop-up window, and we assign it to a new attribute of feature properties called pop-up content. And then we check. This check is probably not required in this case because we know we've got names and IDs for everything, but it's just a little check here. We'll make sure that feature properties exists, make sure that feature properties content exists, and if both those criteria are met, which seems rather a strict criteria to me, but you know, I'm just copying somebody else's code, then I'm going to use the bind pop-up on the layer, and I'm going to bind the properties, the pop-up contents, to the pop-up on the layer. Right, I understand what a layer and the difference between layer and feature is now. Now I understand what layer and feature is. Now I've thought about this. Okay, feature is the GeoJSON file that's been read. The one that's the object in the GeoJSON file that's being looked at the moment. So France or the United Kingdom, a particular country. What LGeoJSON doing? What LGeoJSON is doing, the function that's calling this, yep, LGeoJSON on each feature. So LGeoJSON. But what it's doing is creating a layer from each GeoJSON feature that is going to be added to the map. Each individual GeoJSON feature is being turned into a leaflet layer. Okay, I'm going to talk about the difference between GIS layers and leaflet layers in a moment, but in retrospect, I should have done beforehand. So in this case, feature is the GeoJSON object. Layer is what we're making in leaflet, which we're going to stick on the map. And the layer has a pop-up, but the feature doesn't, because it's just the text that's been read out of the GeoJSON file. Okay, so GeoJSON file, whole system, lots of different GeoJSON objects. Okay. LGeoJSON takes that whole column list of GeoJSON objects and starts processing them and adding them to the map. It takes each GeoJSON object and pumps it through the style, applies the style, and then runs the on each feature code on it. This one. So one country is coming into here at a time. We're grabbing that country is defined in the feature. So that's the GeoJSON basically. That's that GeoJSON object. This is the layer that's going to be put on the map once that GeoJSON object has been processed. And what we're doing is adding this pop-up to the layer. Yes, that's the crux. Okay, the very next slide. Probably this one should have become 4. In GIS terminology, we're used to a vector layer being a collection of spatial objects that share attributes. A shapefile, for example, ArcGIS feature class. That's what we're used to calling a layer. In Leaflet, anything that can be added to the map is a layer. So think of it as a sort of layer cake whereby you've got your base map at the bottom, then your overlays of creamy custard, and then on top you've got sprinkled with jelly beans and hundreds of thousands, which are your map tools, your controls and your zooms and things like that. Leaflet supports layer group and feature group objects that allow you to group individual layers together so that you can manage them as you would an ArcGIS feature class as one item. And I'll show you that and then we'll have a break. Okay, so here's the pop-up there. Okay, so here in this code, pop-up country 1, what I end up with is a map with one layer for each country. One leaflet layer for each country. Here, I'm going to create a leaflet, a layer group, add all those GeoJSON, individual GeoJSON layers for each country to the group, and then I can just manipulate the group all together. So I can turn the group on, turn the group off, take all the data out, everything out the group, etc., etc. So this is exactly the same. The on each feature is the same as 4. We define the map. So in this case, I create a global variable called var country group as an empty layer, leaflet layer group. Note this is a global variable, not within any function. So that is visible everywhere, including inside the closure. So we can see things. So a closure is like standing in a sort of one-way mirror or one-way viewing thing. So you can see out the things outside. The person in the closure can see things outside, but the outside can't see what's in the closure. So I create my layer group called country group. Just this is exactly the same as before, but I run my on each feature. But instead of just adding the layer, each country as it comes through this function to the map individually, I add them to the country group, and when the country group's filled up, I add the country group to the map. And that gives me one layer, or one layer group, that contains all the layers for each country. All right, there we are. We've got to the layer group. That's just repeating here. Okay, let's take a break, and we'll see. We'll do some more advanced. I just want to run through just a slightly more advanced combination, and then we'll go through the assignment. Okay, so 10 past. Excellent.